You are welcome to chemistry class. In today's class, we shall be looking at the topic calculation involving acid-base titration. And here are the learning objectives for today's class. At the end of this lesson, students should be able to solve practical problems related to concentration terms, and students should be able to determine the relative molecular mass of a substance, be it the acid or the base, that is involved in acid-base titration. So these are the major learning objectives of today's class. Solve practical problems related to concentration terms, to determine the relative molecular mass of a substance, be it the acid or base, that is involved in acid-base titration. Determination of relative molecular mass of a substance. Of course, the relative molecular mass is represented by RMM, and that's the short code for the relative molecular mass. In the determination of the relative molecular mass of a substance by titration, two things are important. The first is the concentration. That is to say that the two solutions, the acid and the base, must be a standard solution. A standard solution is a solution whose concentration is known. So that is to say that in this experiment or in this calculation, the acid and the base that must be used or that should be used must be a standard solution. So it implies that you'll be given the concentration of the acid and the concentration of the base. Another important thing we should consider is the provision of balanced chemical equation of reaction in order to establish the mole ratio. So I'll repeat again. Two things are essential. The first one is that the concentration of the two solutions to be used must be given. That's the acid and the base must be a standard solution. Then there must be supply of the balanced chemical equation of reaction, and this will help to establish the mole ratio. In our previous lessons, we have learned how to calculate the concentration of a solution, and we have said that the concentration of a solution for our whole level can be expressed in terms of the number of grams of solute which dissolve in a given solvent, and that is the mass concentration, which is usually in gram per dm cube. Concentration can also be expressed in number of mole of solute that dissolve in a given solvent of a solution, and that can be expressed in mole per dm cube. In today's class, we shall see how to calculate the concentration of a solution, and at the same time use the concentration to determine the relative molecular mass of a substance. Okay, I will want us to take a close look at this question. Work example 1. 19.80 cm cube of a solution A containing 1.15 gram of hydrogen chloride, that's the hydrochloric acid, in 250 cm cube neutralize 25 cm cube of an unknown solution B of triisocarbonate 4 salt X2CO3 having a concentration of 5.3 gram per dm cube. Calculate the molar concentration of solution A. Concentration of X2CO3, that's the triisocarbonate 4 salts in mole per dm cube. And lastly, you are to determine the relative atomic mass of element S given the following parameters. Hydrogen is 1, oxygen is 16 in terms of the atomic mass, and sodium is 23, chlorine is 35.5, and carbon is 12. I want us to take a close look at the question. Now, the first thing is you need to identify the quantities that you are given. What are the parameters given in this question? In this question, we can see that the volume of the acid used is 19.80 cm3. That's the title value that has been given. Then we could see clearly that the concentration of the acid has been given. Now, this concentration has been expressed in gram per 250 cm3. So this can be converted to mass concentration. If you observe vividly, you could also see that the base, that's the triisocarbonate 4 salts, is also a standard solution, because as we can see, the concentration has been given, which is 5.30 gram per dm cube. So as I have said earlier on, that in order to determine the RMM of a substance in acid-base titration, it is essential that the two solutions that must be used must be a standard solution, just as what we have seen in this question. Now, we know the size of the pipette, which is the volume of the base, which is 25 cm3. Then we can go ahead to calculate the molar concentration of solution A, concentration of the triisocarbonate 4 salts in mole per dm cube, and thereafter you can calculate the relative atomic mass of element S. From that, we can predict the name of the element X. Now, here is the solution. You need to establish or write the balanced chemical equation of the reaction. From the chemical reaction, we have 2 moles of the hydrochloric acid react with 1 mole of the triisocarbonate 4 salt to give 2 mole of salt with unknown element X, and 1 water and carbon dioxide. Now, as we have seen, we've been given the volume of the acid, which is 19.80 cm3. This is the title value. Here we have the volume in cm3. So we can convert the volume to dm cube by dividing by 1000 cm3, because 1 dm cube is equivalent to 1000 cm3. Here we can calculate the mass concentration of solution A. Mass concentration of solution A is mass in gram over volume in dm cube. So by the time we calculate this, we get the mass concentration of solution A to be 4.6 gram per dm cube. Of course, we can now determine the molar concentration of solution A, which is given as mass concentration over the molar mass. Since we know the molar mass of the solution A, as we've calculated here, you have the mass of hydrogen, then we also have that of chlorine, which is 35.5. Then we're getting the sum, we have the mass to be 36.5 gram per mole. Here we can calculate the molar concentration of solution A, which is mass conc over the molar mass. Here we have 0.126 mole per dm cube, and that is the concentration of the acid. So this is denoted as Ca, and that is the concentration of the acid. Here We are looking for the concentration of the thiocarbonate 4 solution in mole per dm cube. Now from the equation of reaction, we know that the number of mole of acid is 2, number of mole of the base is 1. The volume of acid used given, volume of base given, and the concentration of the acid has been calculated in mole per dm cube, which is 0.126 mole per dm cube. Now we want to determine the concentration of the base in mole per dm cube. Now we are familiar with this formula. At endpoint, the number of mole of the acid and the number of mole of the base are exactly equal according to the balanced chemical equation of the reaction. So from that, we can establish the fact that number of mole of acid to number of mole of base is a constant, which is equal to the concentration of the acid multiplied by the concentration of the volume of the acid, all divided by the concentration of the base and the volume of the base. Now, in order to look for the concentration of the base, we make the concentration of the base Cb the subject. So by doing that, then we can substitute in the appropriate value, then we get the concentration of the base as 0.05 mole per dm cube, and that is the molar concentration of the base. You may like to go over these slides in order to get what the calculation is all about. Okay. Relative atomic mass of the element X, that is what we are about to look for. In order to look for the relative atomic mass of the element X, we just use the formula molar conc of the base is equivalent to mass conc over the molar mass. Since we know the mass conc of the base we've been given, then we also know the molar mass of the base, then we can substitute in our formula. The molar mass can be calculated from this formula: mass conc of the base and molar conc of the base. So the mass conc as given in the question is 5.3 and the molar conc of the base as calculated is 0.05. If we do this very well, we discover that the molar mass of the base is 106 gram per mole. Since we are interested in determining the relative atomic mass of X, then we can say that the atomic mass of thiocarbonate 4 salts or the base is equivalent to 106. Then we can find the value of X. If we do that very well, we discover that the value of X is 23. So to provide the name of the element, we look at the periodic table which element has atomic number 23, and that's obvious that it's sodium. So that is to say that the salt is a sodium salt, sodium thiocarbonate 4, and the element is sodium, as I have said. You might like to go over the slide over and over in order to get full understanding of the calculation. Example 2 now. This is also similar to what we've just done. You need to pay attention, you need to follow with this. A is a solution containing 3.5 gram of an acid HS per dm cube. B is a solution containing 0.05 moles of hydrous thiocarbonate 4 per dm cube of solution. 25 cm cube of portion of solution B required, an average of 26.10 of solution A for complete neutralization. So from the results, we have to calculate the molar concentration of solution A, and we also to calculate the relative molar mass of A, and we've been given the equation of the reaction. Now if you look at it, you will discover that we've been given the concentration of the anhydrous triisocarbonate 5, and that has been shown here as 0.05 moles per dm cube. As we have seen, we know the volume of the base, which is 25 cm cube, volume of acid, a titer value, which is 26.10 cm cube. Now, from the equation of reaction, we can deduce the mole ratio. We can say that the number of mole of the acid is 2, while that of the base is 1. Then we can determine the concentration of A in mole per dm cube, and that's the molar concentration of solution A. Now, from the equation of the reaction, we have this, just as I've mentioned earlier, and these are the other parameters that have been given. So at end point, we know that this formula holds Na over Nb equals to Ca Va over Cb Vb. So in order to find the concentration of the acid, we make Ca the subject. Making Ca the subject, then we can substitute in the appropriate value. Then we get the concentration of the acid to be 0.096 mole per dm cube, and that is the concentration of the acid, molar concentration, since it is expressed in mole per dm cube. Now we have to look for the molar mass of the base. In order to do that, we are aware that the mass concentration is given as the molar mass is given as mass concentration over the molar conc. And since we know the mass concentration that has been given to us in the question, then we divide by the molar concentration of the base, and that will give us 36.5 gram per mole. Hence, the relative molar mass of HS is 36.5, and it is obvious that HS is hydrochloric acid, because if you find the value of X, you discover that the value of X is 35.5, which is chlorine. So HS is hydrochloric acid. I want to believe this is clear enough. So in order to determine the relative molecular mass of a substance, be it the acid or base that is used in titration, we are saying that the two solutions must be a standard solution, then the equation of the reaction must be provided in order to establish the mole ratio. Once those parameters have been given and they've been taken care of, then we can determine the relative molecular mass of a substance. And here, it's your own question. (22.0 cm cube of a solution containing 0.10 mole of HCl per dm cube of solution neutralized 20 cm cube of a solution containing 7.6 gram of anhydrous base, which is R2CO3 per dm cube of solution. We don't know the element R. We have to write a balance equation for the reaction, and B1, we have to calculate the molar concentration, and lastly, the molar mass of the base. This must be submitted via WhatsApp, and we have the deadline. Which is Tuesday, 21st of July, and this must be submitted on or before 4 p.m. And this brings us to the end of today's class. If you remember vividly, we stated our learning objective that at the end of this class, you should be able to calculate concentration of a solution, and that you should be able to calculate the relative molecular mass of a substance that is involved in acid-base titration. All the best. Thank you for listening. I am your host, Ajilore Olushola. Goodbye.